Guys, so on to 47. So 47 is a little confusing because you get all the information in the problem. You have P, V, N, and T. So you might be wondering how this is going to work. So what we're trying to find is what the gas is. And the way that you tell what you're going to be able to tell what the gas is by finding its molar mass. So we know what the grams are. So now we need to find what moles we get from this V, this T, and this R, so that we can divide it by this to find what the molar mass is. That might sound confusing, but first let's try to do the problem so that it'll maybe make more sense. But before we do the problem, let me switch colors. This pink, because apparently it's the only one that shows up that isn't black. So we need to convert because it needs to be in, so that this R works, liters, ATM, moles, and Kelvin. So we're finding moles, so we don't really need to worry about converting that right now. We do need to worry about converting this to liters. So we do 1 liter, because that's our desired unit, over 1,000 milliliters. Let me do that in my calculator real quick because, believe it or not, I can't really divide like that in my head, LOL. Even though it's going to be 0.752 liters. Now, to convert temperature, we need to add 273.15 so we can get Kelvin. So we're going to get 62 plus 273.15. And that's going to get us 335.15 K. Yay! That's not really a 5. Yay! Now we have all our correct conversions. So we're going to do PV equals nRT, except we're looking for N, so we're going to get PV over RT equals N. We're going to do that right here. So we're going to do N, number of moles, equals P, 1.98 ATM, times V, 0.752 liters, over R, 0.08206 liters ATM per mole K, times K, temperature 335.15 K. Now imagine this is written well and not like a 3-year-old wrote it. So K cancels, liters cancel, ATM cancels. That's how you know you have all the correct units. All we're left with is this lovely little mole. So when we do the math, we're going to get, I did it for myself earlier, but I'll do it with you right now. So 1.98 times 0.752 divided by 0.08206 times 335.15. Oh, oops, 1 second. Times, or divided by 0.08206 times, I typed that in wrong, 335.15. And you should get 0.54 as your number of moles. So N is going to equal 0.54 moles. Now you might be wondering, so what do I do with that piece of information? So if you remember, the way to convert from grams to moles is with molar mass. So now that we know, V, P, and T are irrelevant now, so I'm just going to erase those. All we care about is that the number of moles that we get from those numbers is 0.54 moles, so I'm going to write that up here. and for this equation is 0.54 moles. So now, when we go to find the correct, so LOL, if I could speak, that'd be amazing. So now we need to go through every single one in the practice problem, or all the ones in the practice problem, and find their molar weights and divide 2.49 divide 2.49 by each of their molar weights, and whichever one is equal to 0.54 moles, that is going to be our mystery gas. Woo! Doesn't everyone love that? So, LOL, I don't think I have a... Yeah, no, she didn't give me a chart, so 1 second, I need to look at the periodic table, because I don't know of these off the top of my head. So our first gas is going to be SO4, no, SO2. SO2. So S is 32. O is 16 times 2. I'm going to add these together, and this is going to equal 64 grams around. We don't really need to worry about the specifics. We just need to get it in the ballpark of this. So now we're going to do 2.49 grams times 1 mole, because this is grams per mole, sorry guys, over 64 grams. And if that is equal to 0.54 moles, then our gas is SO2. So let's see. My calculator. 2.49 divided by 64 is equal to 0.039. This is not this. So SO2 is not our gas. Darn. Darny darn darn darn. Now we're back to trial and error, because that's what half of these questions are. So, LOL. We are just going to push through this. Next is SO3. So, SO3. S is 32 again. O is 16 times 3. 16 times 3 plus 32. That's going to be 80 grams per mole. You know anything about this? This is probably not going to work because this is even more than the last one. But we're going to do it anyway. So we're going to do 2.49 grams times 1 mole over 80 grams. What do we get? 2.49 divided by 80. An even lower number, 0.031 moles. That is not equal to the moles we're trying to find. So SO3 is not the correct one. Oh no. Darn. Now, let's move on to, ow, my fingers, NH3. So NH3. Fudge. If that looked good, it would be great. 3. So nitrogen is about 14. Hydrogen is about 1 times 3. This is 17 grams per mole. Maybe we're in the ballpark. Maybe. Who knows? 2.49 grams times 1 mole over 17 grams equals 2.49 divided by 17 is 0.15, or it's 146. 146 moles. That is way too big. Or we just oh, this is zero. Shoot, have I had it wrong this entire time? This is 0.054. We had that right earlier. It was right earlier. It's 0.54. Sorry, guys. I think. Right? Let me check my calculations. 2.49 divided by... Yeah. Sorry, guys. I'm slightly dyslexic, but with numbers. But anyway, none of those have equaled that anyway, so it doesn't matter. But this is way too big for this, so it's not going to work out. I hope that didn't confuse you too much. If you did in your calculators, you were probably screaming at me that I was wrong for like 5 seconds. Anyway, they've also been wrong though because 0.038 is nowhere near 0.054 and 0.031 is nowhere near 0.054. So we know that those are wrong still. So if you look at your answer key, and you know that 0.14 is way too big for this. So if you look at your answer key, you know that NO2 is going to be right. So we're just going to go straight to E, do NE. So NE, its molar mass is around 20. So NE, 20 grams per mole. So we're going to do 2.49 grams times 1 mole over 20 grams, which is equal to 2.49 divided by 20, 0.1245 moles. That's way too big, so it's not that. Darn. So that means we're left to our last one, or not our last one, but the answer D for D, which is going to be NO2. So nitrogen, 14, oxygen, 16 times 2. Add those together, we're going to get 46, around 46. This is also just an estimate because we're just trying. The reason we're not finding exact things is because we're trying to not waste time because this is a test, or in theory, this is on the test, and you're just trying to get in the ballpark. Make sense? I'm not worried about the decimal places because at the end of the day, none of them have even come close to this, and the decimal places aren't really going to matter that much. So, when we're rushing. So, we're going to do 2.49 grams times 1 mole over 46 grams. Grams cancel. So that equals 2.49 divided by 46 is equal to 0.5, 0.054 moles. Yay! We know that this is equal to this. So we know that NO2 is the correct answer because its molar mass allows us to get the same thing as the moles that we got from PV equals nRT when we convert this. When we convert grams. Sorry, let me say that again. When we convert grams using its molar mass, we get the same amount of moles that we found from PV equals nRT with its pressure, volume, and temperature. Does that make sense? If not, email me. My emails are open. Good luck.